Hey students, this is lesson 9-2, quadratic functions. We're going to learn how to graph quadratic functions in standard form, which is y equals ax squared plus bx plus c. That's standard form. All right, go ahead and do the review. If you want to pause here, you can check back with your answers. All right, so a couple of properties that are going to help you graph quadratic functions. The graph of y equals ax squared plus bx plus c, where a is not equal to 0, has a line x equals the opposite b divided by 2a as its axis of symmetry. So that means to find the axis of symmetry, which means the line of symmetry of the parabola, you take this number in your equation and take the opposite of that, that's the top there, and then you multiply by 2 times that number and divide those two. So, I'll explain later on in the chapter why that is, but for now, you should just know that that's true. So if I have this quadratic equation here, a is equal to 1 because it's 1x squared, b is equal to 3, and so I'm going to take the opposite of b, which was negative 3, and divide that by 2 times a, which is negative 3 over 2, or negative 1/2. And that's that axis of symmetry. So x equals negative 1/2, which is a vertical line at x equals negative 1/2, 1.5. All right, in this one, a is equal to 2. You can see that there because it's 2x squared. B is equal to negative 2 because it's plus negative 2x. And so I'm going to take the opposite of b, which is the opposite of negative 2, divided by 2 times a. A is 2. Opposite of negative 2 is 2. 2 times 2 is 4. So the axis of symmetry for that equation is going to be at x equals 1/2. In this equation, a is negative 2. B is 4. Take the opposite of b, divided by 2 times a, which is negative 4 divided by negative 4, which is positive 1. So the axis of symmetry for that one is 1. All right, when you substitute x equals 0 into the equation y equals ax squared plus bx plus c, you get y equals c. So the y-intercept of the quadratic equation is c. What that means is, I'll just give you a quick example. Let's say we have this quadratic equation, x squared plus 6x minus 5. Well, if I put 0 in for x, in both those places, what I end up with is y equals negative 5, because 0 squared is 0, and 6 times 0 is 0, and 0 plus 0 minus 5 is negative 5, and that is the y-intercept of the graph. So a couple of important things that you can use to help you graph things. We're going to use the idea that the graph will be symmetrical, it's a parabola, and we're going to find the axis of symmetry, which tells us where there's a line of reflection, and then we're also going to find the y-intercept. So here's our first problem: y equals x squared minus 6x plus 2. So the first thing we want to do is let's find the y-intercept. That just means we're going to put 0 in for x and 0 in for 6. And I'll do this work, but eventually you'll just see that it's actually just this number is the y-intercept, the number you're adding on to the end, a constant. So y equals 0 squared minus 6 times 0 plus 2, and that's equal to 0 minus 0 plus 2, which is 2. So the y-intercept is at 2. So let's go ahead and put that on the graph right now. It's about there, 2. All right. And then we're going to find the axis of symmetry using the property. The axis of symmetry is this: x equals the opposite of b divided by 2a. So we need to figure out what a and b are. A is the coefficient of the squared term, which is 1. So just put a note over here, a equals 1. And b is the coefficient of the linear term, or the x term, which is negative 6. So we're going to do the opposite of b, which is the opposite of negative 6 divided by 2 times a. A is 1. That's 6 divided by 2, which is 3. So this graph is going to have an axis of symmetry at x equals 3. Remember, any x equals equation is a vertical line. And so I'm going to put that on right now, a vertical line at x equals 3. Right there. Okay. What that tells me is that that's the line of symmetry. So if I have a point here at 2, I'm going to have a point also over here at 2. All right? And that's going to help me make this graph. All right, so one other thing we can do is we can find like one more point just to help us out here. An important point to graph would be the vertex. And the vertex will be right on this axis of symmetry. And the value of x there is 3, so what I can do is just take my function and find the value, the output of that function when the input is 3 to get that vertex point. So I'm just going to substitute 3 in for x. And that gives me 9 minus 18 plus 2, which is negative 9 plus 2 is negative 7. So my vertex is at negative 7. That's about right there. And now I know what a parabola looks like, so I have 3 points that are going to help me. It's going to curve up. Ran out of room on this side of the graph, but over here I can, if I want to get it a little more accurate, I could find some more points for some negative values, but for just a general graph, I think that's okay. All right? So go ahead, you try it. You can check back with your answers here. All right, in lesson 9.1, you use h equals negative 16 t squared plus c to find the height h above the ground of an object falling from an initial height c at time t. If an object projected into the air given an initial upward velocity v, notice that v is the coefficient of the linear term there. The formula is negative 16 p squared plus b times c plus c gives approximate height above the ground. This was something actually discovered by Newton. So Daniel kicks a soccer ball up into the air with an initial upward velocity of 64 feet per second. So that's v. The ball is 2 feet above the ground when it is kicked. How long will it take for the ball to reach the maximum height? How high above the ground will it be? What is the range of the function? All right. So our equation is this. H equals negative 16 t squared plus v times t plus c. Now c is the y-intercept, which in this thing is the value of the function when time is 0. So the beginning value, which is right here. The ball is starting 2 feet above the ground when it is kicked. So we're going to replace c with 2. And the initial velocity, that's v, is 64 feet per second. So we're going to replace v with 64. And that's our function that we're going to use for this. Now we want to know a couple things here. How long will it take the ball to reach its maximum height? From 9.1, you know that quadratics with a maximum will look like that. So the maximum height will be at the vertex, which is on the axis of symmetry. So we're going to use that idea to help us find that. Let's first find the vertex, and that'll help us find the maximum height. the vertex equation is x equals the opposite of b over 2a, and a equals negative 16, and b equals 64. So we're going to do negative 64 divided by 2 times negative 16, and 2 times negative 16 is negative 32. Negative 64 divided by negative 32 is 2. So our axis of symmetry is x equals 2. So this is 2 right now, we know that. And to find this point now, we're just going to substitute 2 into our equation. So we're going to find h of 2, which is negative 16 times 2 squared plus 64 times 2 plus 2. If you simplify that, you get 66. So h of 2 is equal to 66. So that's the maximum height. We'll just write that here. That's the maximum height. All right. And now the other thing we want to find is the range of this function. The range is the possible output values. And if you just think about this graph here for a second, think about this. Output is the y-axis, so this is the output axis. So what is the greatest output, and what is the least output, at least the output that makes sense? And this is when it hits the ground again at 0 feet. This is in feet. So the only values that make sense here are values from 0 to the maximum, 66. So we're going to say the range, which is the y values. Remember that from our function work. And I'm going to write this in interval notation because I like that. So that goes, it includes 0. That's the minimum value. And the maximum value is 66. And it includes that. So that's interval notation. You could also say this, y is less than or equal to 0 is less than or equal to 66 for the range. All right, I'm going to let you try that. Check back with your answer. All right, that's it for today. Do a quick lesson check here. Explain how you can use a y-intercept vertex and axis of symmetry to graph a quadratic function. The y-intercept, that represents the point where the graph crosses the y-axis. The vertex represents the minimum or maximum point. And the axis of symmetry is a reflection line through the vertex of a parabola. So what you could do is find the axis of symmetry. Let's write these in order of the way you should do it. First, find the axis of symmetry. And that is, let's just say our function is this. Use a little notation to help. ax squared plus bx plus c. All right? So let's just call the axis of symmetry, it's x equals something. It's actually the opposite of b divided by 2a. Okay, and then we're going to use a to find the vertex. Actually, we're going to use this x value to find the vertex. So we're going to find this point, the vertex. So we're going to use a line of reflection, whatever its value we get here, to find the vertex. And that point will be the x value that we just got, and then the function value for that x value. And then we're going to find the y-intercept, which is 0 and c, remember, constant in the equation. And then we're going to use the axis of symmetry to find another point by reflecting this y-intercept. And that's it. All right, I'll see you tomorrow.